Everyone hear me and see my screen? Cool. As usual, this guy's being recorded. Does anyone have any questions before I dive in? I don't think that this worksheet, I think, is going to be pretty quick. I don't think it's going to last the full 50 minutes. So, have people looked at it all? Is there anything that people want me to start with? Okay, then I will go straight through. The graphs. Okay. So I guess you mean questions 3 and 6 there?
Yeah, you could just go in order though, that's fine.
Okay, cool. So say we've got this guy, if the limit as x approaches from the negative side of f of x is equal to the limit as x approaches from the positive side, right? That's what these guys mean, or sorry, not from the negative and positive side, from the lower and the greater side. But f of 2 is equal to, both equal -1, but f of 2 is equal to 1. What can we say about the limit of f of x as x approaches 2? So if I've got my graph here, let's say 1, 2, and sorry, 2, 1, 2. So as x approaches 2, it looks something like this. And then from the right side, we also have something going on here that approaches 2. And then we have over here, this is, let me just smooth that out. So this is a function that could be described by this. What can I say about the limit of f of x as x approaches 2? So this is kind of a prime example of the limit is not necessarily equal to the actual value, because there's a point discontinuity, or what's sometimes called a removable discontinuity, where this guy, where the f of x value is not equal to the limit of f of x, but the limit of f of x is going to be -1, because that's what it's approaching from both the left and the right side. That's just what the limit means. It's what is approaching from all the sides. Does that make sense? Cool. So if the limit as x approaches -1 of f of x is equal to -infinity, and the limit as x approaches 1 from the positive side of f of x is equal to -infinity, then the limit of f of x, or the limit as x approaches 1 of f of x, what is this guy? Does anyone know what this guy is?
Would it be C?
So this one is actually like a little bit ambiguous. Sometimes we would say that the limit is equal to -infinity, and sometimes we would say that the limit does not exist. The answer key here is looking for B, but I would actually normally lean towards saying that C, because the limit is not in the real numbers. Informally, we would usually say the limit is equal to -infinity, but formally we would normally say that the limit does not exist. So I guess your answer key here is looking for the less formal thing of saying that the limit approaches -infinity. Does that make sense? So another way of thinking about this is like, am I just looking for a limit in the real numbers, in which case it does not exist? Or am I allowing it to also approach positive or negative infinity, in which case we want that it's equal to -infinity? But yeah, that's a bit of a trick question there, but don't worry too much about it. So use the graph to find each of the following limits. So g of x as x approaches 3. So as x approaches 3, I come from the left side and it's approaching 2, and I come from the right side and it's approaching 2. So that tells me that g of 3 is going to be equal to 2. Then as x approaches 5, g of x is going to be, so I'm coming from the left side now, and from the left side, I get lim x negative of 5 is equal to -2, right? And then the limit of x positive approaches 5 is going to be equal to +3, right? So what does that tell me? If the left limit and the right limit don't agree, then the limit does not exist. And here for number C, or for letter C, we're going to use the same rule that we did before of if it approaches positive or negative infinity, we say that it approaches positive or negative infinity instead of saying that the limit does not exist. So I just follow this guy on down. It looks like it's just a line that's going to be decreasing as x decreases. So, oh, sorry, no, I'm coming at it from the wrong side, not negative infinity. This guy right here is also a line that decreases as x increases. So now this guy is going to approach. Somebody shout at me.
Negative infinity.
Yeah, exactly. So it just keeps on going down and it's approaching negative infinity. So a company training program has determined that on average, a new employee produces P of S items per day after S days of on-the-job training, where P of S is equal to 63S over S plus 8. What is, find and interpret the limit as S approaches infinity of P of S. So, does anyone know how we're going to go about doing this, or the rule of thumb that we're going to use? So when we have like let's say f of x over g of x as x approaches infinity, limit as x approaches infinity, we're really going to care about two things: how fast the top is growing / shrinking, and how fast the bottom is growing and shrinking. So assuming these guys are polynomials, I'm going to check what's the biggest power of this and what's the biggest power of this. Because if one of them has a bigger power, as x goes off to infinity, it doesn't matter what the coefficients are, it doesn't matter what else is being added, they're going to make very little difference because the lead term is going to grow much, much faster than all of the others. In this case, we have that they have the same power. This is s to the 1 on top and on bottom. So that tells me that the limit is actually just going to be the coefficients of the coefficient of the top lead term divided by the coefficient of the bottom lead term. So in that case, that's just 63 over 1, which we normally write as 63. So the two things we tend to care about are when x approaches infinity, or s in this case approaches infinity, are what are the powers of the lead terms, basically how fast is this guy going to grow as x goes off to infinity? And what are the coefficients of the lead terms? And the coefficient matters for two reasons. If they are the same power, then that coefficient is going to be the thing that is going to be the limit, or the ratio of the coefficients is going to be the limit. And then the other thing we care about is if the top one has a bigger power. So let's say this was s63s squared over s plus 8, then this would go off to infinity. But if this was negative 63s squared, this would go off to negative infinity. So if the top, or if it's going to be a negative, is also going to be determined by the lead coefficients. So that's just going to be if the top divided by the bottom lead coefficients are negative, and it doesn't matter if in fact, in that case, we assume that but basically we would only care about in the case that the top is a bigger lead coefficient, or bigger power than the bottom. So find the limit of these guys as x approaches -3. So what should be your first instinct for this? Your first instinct should be check if I can actually plug in -3. And if I can, then cool. My job is done. It's just going to be, because this is going to be continuous almost everywhere. And if it's continuous at almost everywhere, then the limit is going to be equal to the value that we get. But if we do that, we get 0 over, then we get, that's 9 minus 3 minus 6 is 0. 0 over 0 is undefined. So what I need to do here is I need to factor it. So the top is going to be, this is difference of two squares. So it's going to be x minus 3 and x plus 3. And then the bottom here is going to be, we'll get x plus 3 on the bottom and x minus 2, right? We need two things that multiply to give a -2 and add to give me 1. So now I can cancel this and this, and that means that it's going to be equal to x minus 3 over x minus 2. And now I can plug in -3 to this, and whatever that is going to give me my limit. So basically, these guys will cancel everywhere except it's going to be undefined at the one point where it's going to be 0 over 0. Everywhere else is going to be 1, right? So that's going to tell me that this guy, this function, looks like this with a hole at x equals -3, which is the point where these guys are equal to 0. So now I can just plug in -3 to this, and that's going to give me -6 divided by -5, or 6 over 5. Does that make sense to everybody? Cool. So this is another case where we'll have something very similar. And if I were to plug it in, I would get 0 over 0. But I can basically treat the bottom here as a difference of two squares. Just, we're going to get one of those is going to be with a square root, or those, except it's going to have a square root instead of just x to the 1 here. So I can factor this guy into the square root of x minus 6 and the square root of x plus 6 divided by the square root of x minus 6. And then I can cancel these, and I am left with 1 divided by the square root of x plus 6. Now if I had to just plug in 36 here, I will get that this is going to be equal to 1 divided by 6 plus 6 is equal to 1 12th. Does that make sense to everybody?
Yeah.
Cool. And now somebody, I already told you the rule for C. Somebody shout at me. So they both have the same power. So what does that mean that the limit as x approaches infinity is?
3/7.
Exactly. It's just the ratio of the coefficients. Now here we've got x squared on bottom or on top and x to the 4th on bottom as x approaches infinity. What does that mean that we're going to get? So the top is growing much, Sorry,
A positive infinity?
not positive infinity.
Oh, negative?
No.
0.
Exactly, 0. Because the bottom here is going to grow much, much faster than the top because we've got x to the 4th as opposed to x squared. But now we've got x to the 4th on top and x squared on bottom. So that tells me I'm going to get either what or what. The top is growing much faster than the bottom.
So this one would be positive or negative infinity?
Yeah, and how do I know if it's positive or negative?
Because in front of the x, there's no negative, so it would be positive.
Yeah, because in front of both the x to the 4th and the 7x to and the 7x both have positive, sorry, the x squared both have positive coefficients. If either the top or the bottom had a negative coefficient, then this would be negative infinity. Does that make sense?
Yes.
And things can also get a little bit funky if I were to say give you guys the limit as x approaches negative infinity of x to the 4th divided by x cubed. Here, when we're going off to negative infinity, I have to ask myself, basically, so the top's going to grow much faster than the bottom, but I still need to ask myself, is the top going to be positive and is the bottom going to be positive or negative? And in this case, the bottom's going to be negative. So this guy right here is going to approach negative infinity. So that's something to keep in mind. If you're approaching negative infinity, you also have to keep in mind what the lead power is. If it's going to be, if they're odd, then that's basically multiplying by negative. So given the graph or function definition, identify the intervals where the function is continuous, or identify the values of x where the function is discontinuous. So use the graph to identify the variable x values where g is discontinuous. Also identify the condition that does not hold for any point of discontinuity. So this, just looking at this, this is the same graph that we had before, right? And we identified a discontinuity on that graph. Do you remember what it was? We have this big jump right here, right? So we know that that tells us that at x equals 5, there is a discontinuity. But everywhere else it's going to be continuous, right? So from negative infinity to 3, it's defined by this line. From 3 to 5, it's defined by this line. And then from 5 to infinity, it's defined by a third line. And lines are continuous everywhere that, so the only places that we have to worry about are the two breaks in how it's defined, which are at x equals 3 and x equals 5. But we saw at x equals 3, it's continuous. So we also have to identify the condition that does not hold for this point of discontinuity. What is that condition? So your answer key is saying that it's condition 2. I'm guessing that condition 2 is just that the left limit as x approaches 5 of g of x is not equal to the right limit. G of x. That I'm guessing that is the definition that they're looking for. Another possibility would be like a whole discontinuity. So if we have something like this, the limits agree, but this point is just not defined. And we could also have something like that, which are essentially the same type. They're both sometimes called whole discontinuities. So does that make sense to everybody? I believe, Shannon, you asked questions about the graphs, right?
Yes, I did, but that helped. Thank you.
Cool. And now identify the intervals where each function is continuous. So what is going to make this guy discontinuous? What conditions will give a discontinuity for this guy? Oh yeah, sorry. Another type of discontinuity is, so let's say this is just going back to the previous question, something like the tan function, where you have something going off to infinity and then immediately being redefined. That's going to be relevant for this guy. Things going off to positive and or negative infinity. What is just kind of the classic way for generating a discontinuity? Probably the first way you ever saw.
A 0.
Yeah, dividing by 0, right? So when am I going to be dividing by 0 here? So we'd have 2x plus 1 is not allowed to be equal to 0, and 3x plus 2 is not allowed to be equal to 0, right? So then I would have 2x is not allowed to be equal to -1, right? And x is not allowed to be equal to 1/2. And then this guy, I'm just going to divide everything through by 3 at first, and that's going to give me x plus 2 is not equal to 0, and then x is not equal to -2. Sorry, this should be -1/2. So these guys are the points of discontinuity. So what does that tell me? That how would I write this out in interval notation for where it is continuous? Somebody shout it at me or toss it in the chat, whatever you want. Bueller. What about Jack? Do you know?
Could you ask the question again?
So it's discontinuous at x equals -1/2 and x is equal to -2. How would I write this out as an interval for where it's continuous?
-infinity to -2, -2 to -1/2, and then -1/2 to infinity.
Exactly. Sorry. -2 to -1/2 to infinity. And all of these guys are going to be parentheses because it's not defined at the border. And then strictly speaking, you should put unions signs in the middle, although I doubt you will ever be docked more than like half a point or a point for not doing that. Strictly speaking, you should have those unions there. Cool. What about Q here? So this guy right here can be thought of. Oh, so there's I guess just a useful little thing to remember is that any polynomial is going to be continuous. So these guys, this is a polynomial, right? It's just sums of powers of x. So it's going to be continuous and we don't have to worry too much. So this guy is going to be continuous everywhere. So how am I going to write that out?
-infinity to infinity.
Perfect. And then this guy, 11 is obviously going to be continuous everywhere that's defined. And then 11, so that means that it's going to be continuous in this range and in this range. This guy right here is a polynomial, so it's going to be continuous within this range, or on the insides of this range. But what do we still have to check? For a piecewise defined function, we always have to check the boundaries between these guys, right? So what does this function actually look like? Let's draw the graph of it. So from x, from -1 on, we have that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have that, it looks like that. From 3 on, it looks the exact same. And then I have x squared plus 2. So on the right side, when I plug in 3 for the border, that's actually going to agree. So, and then we go down. I don't really care that much about how this parabola looks. I really care about just what it's equal to on the other side. So if I plug in -1 to this guy, I would get, actually, you know what? It's very easy to figure out what that looks like. So if I plug in -1 to that, then I would get 3. So where is the discontinuity here?
At -1.
Cool. So basically the only thing you have to do is check if each of these guys is going to be continuous everywhere. or continuous everywhere within its range, then you only have to check the borders to see if they agree, and clearly 11 is not going to be equal to 1 squared plus 2. So there's going to be a discontinuity at -1. So how am I going to write that out? Well, once somebody shouts this answer at me, you guys will presumably be free. So somebody shout at me.
Negative infinity to -1, and then -1 to positive infinity.
Yeah. And again, it's good to put the union there, because that's just the meaning of it, that of how you combine two sets. I don't have any other material other than the recitation worksheet for you guys, so I will stick around to answer questions that any of you guys have, but I think you guys are free now.
Thank you.
Thank you.
Thank
Have a good
you.
night.
Thank you.
Have a
Nice.
good one, guys.
Hi, I just had a quick question.
Sure.